Good day, everyone. It is great to be a part of the MEDINFO 2021 conference. It is nice to be able to virtually interact with colleagues worldwide. I am Tim, a physician by profession, but a researcher at heart. I am currently working at the Research Institute for Tropical Medicine in the Philippines, and I would like to share our abstract presentation on our experiences in using KoBo to collect and KoBo Toolbox. It is estimated that 59,000 human deaths occur annually worldwide due to rabies. In the Philippines, there has been an average of 231 deaths per year in the past decade. In this study, we wanted to determine gaps in the dog population and rabies knowledge in the province of Bulacan. One of the primary challenges in conducting household surveys in the Philippines, particularly in densely populated areas, is that there is no available household census in most communities. Since simple selection of household following the main road would cause bias in household selection, we have conducted community mapping wherein the study team collected all households' Geographic Information System or GIS coordinates for all communities included in the study. In these pictures, you can see that we had to conduct a part of the survey in a permanently flooded region of the municipality. Our data collectors had to wade floods and wear these fancy jumpsuits. We conducted the survey in sparsely and densely populated areas. Here you can see one of our field managers having difficulty getting a GPS lock. To reduce bias, we have mapped all the households of the communities included in the study. GIS data was collected using Garmin eTrex 10. Here you can see the various terrain our data collectors had to go through. Although we were able to eliminate paper forms for data collection, we still had to use paper-informed consent forms. In choosing our data collection platform, we took into consideration several factors. Since we needed to conduct household surveys in densely populated and sparsely populated or rural communities, we needed a platform that allows for offline data entry if mobile data is not available. We also needed a platform that provides differentiated user privileges for data collectors, field managers, and researchers. Since both English and Filipino are spoken in the chosen site, we needed support for multilingual forms. We also had a limited budget and time, so we preferred a platform that does not require server setup. Finally, to facilitate more accessible data collection and less training time, we wanted a platform that allows for skip logic and compute functions. We identified KoBo Toolbox as our electronic research data collection platform as it meets all our studies needs. KoBo Toolbox is free and open source software initially developed for humanitarian use by the Harvard Humanitarian Initiative, Harvard T.H. Chan School of Public Health, and the Brigham's and Women's Hospital. Although KoBo is rarely discussed in informatics literature, it is currently being used in different research studies, particularly in Africa. In this section, I would like to emphasize the process in data collection using paper forms. First, of course, is we need to develop our data collection tool based on study variables we identified. We then have to print the forms, and if all is well, we can proceed with data collection in the field. Take note that data collectors need to be trained well in regards to the skip logic of the forms. After that, data needs to be encoded and exported to our preferred stat software. Only after these steps, we can then proceed to data analysis. However, there is a possibility that errors in paper forms are discovered in the field. If this is the case, and depending on the error discovered, data collection may be needed to be postponed, redesigned, and reprinting of the forms needs to be done. When using electronic data collection, we streamline the process. Since data is directly encoded in the platform, we do not need to print and manually encode the results of the data collection. Additionally, KoBo Toolbox generates reports based on the sent data. If errors are discovered, they can easily be fixed and updated on the client devices. For the next section, I'll be discussing the data collection setup that we use for the study. After finalizing the contents of the data collection instrument, the electronic form was created on Microsoft Excel using the XLS form standard. Range, logical checks, and skipping logic were integrated into the electronic form. The XLS form was then uploaded through the KoBo Toolbox website. KoBo Toolbox also allows for form design using its web-based form designer. The electronic form underwent field testing to determine if there were any errors or logic faults. We used 12 smartphones with KoBo Collect, and each was assigned to one data collector for the whole duration of the data collection. Each smartphone had a Google and KoBo account, which allowed us to associate the collected data to a specific smartphone and data collector. The blank form was downloaded from the KoBo Toolbox server to the smartphones. After each data collection day, the completed data was sent from the smartphones to the server. The platform does not allow any smartphones to access aggregated collected data from the server. This adds another layer of security. For the next section, we'll be showing the results of our community mapping. In this video, you can see the results of our community mapping. I'd like to emphasize that a lot of the houses are located behind other houses along the main roads. Using a simplistic systematic sampling would likely not have been able to survey these households. Community mapping was done from January 15 to 31, 2020, and we identified a total of 9,173 households in the target communities. The survey was done from February 4 to 19, 2020 among 727 households. No smartphones use failed in the study, and the team did not encounter any issues during data transfers from the smartphones to the server. Minor reconfiguration of the electronic form was done during the first few days of data collection to correct some range and logic checks. KoBo Collect allowed data collectors to reach even remote areas without difficulty of bringing heavy paper forms. This made traveling by foot a lot easier, especially during hot and humid days. KoBo Collect was also very useful in locations with no or weak data since it does not require internet connectivity. Data could be collected and stored even if the device is offline. Electricity was not a problem during data collection process as long as the devices have been fully charged before field data collection. The study team reported that checking the data after a day of collection was easier and faster using KoBo Toolbox, as it had a feature where field managers could review the collected data. This way, the field managers could monitor the data gathered remotely and prompt data collectors if there is a discrepancy. Reports were generated once new data is sent to the server. Downloading datasets from the system was straightforward given the CSV export format, which could be easily converted and used in statistical software for data processing, cleaning, and analysis. Data cleaning was easier as well, as KoBo Toolbox had strict built-in validation to ensure the completeness of collected data. The skip logic condition and validation criteria were well handled by the platform. KoBo Toolbox, although developed for field data collection in humanitarian crises, functions successfully for research data collection in our setting. To expand as a research tool, the KoBo platform could benefit from an electronic consent framework which would allow for a completely paper-free data collection. We successfully conducted a household survey using KoBo as our electronic data capture platform. The use of the platform provided the study team with an economical, time-saving, and more straightforward method of data collection as compared to traditional paper-based methods. One of the major strengths of the platform is its ease of use, deployment, and integration of multilingual forms. Based on its design, we do not recommend its use on longitudinal studies wherein data is needed to be downloaded from the server to the data collection device. Thank you for listening. For our acknowledgement, this work was supported by a JICA, a MedSat project under JAPOR, the establishment of the One Health Prevention and Treatment Network model for the elimination of rabies in the Philippines. We would also like to thank Stephanie Duda from the Vanderbilt University for informing us about these conferences, encouraging us to join, and for her inputs in manuscript content. I have active collaborations and or funding from the following institutions. Once again, thank you for listening.